recording. Okay. Please confirm if my screen is visible. Okay then. Right. So yesterday we were discussing about what bitwise operator. So unfortunately there was the power disruption. So I was not able to continue further. Right. So today we will continue from where we left yesterday. Okay. So I was telling you about what the bitwise OR operator. We started, we have just started to understand bitwise OR operator. So this one. Okay, bitwise OR. Right. So according to the truth table, if you want to take any two inputs, right, and if you want to perform the OR operation, okay, A or B, right, and the possible combinations would be like 0 0 0 1 1 0 1 1. Okay, what I was telling you yesterday, if at least one of the inputs, if at least one of the inputs is 1, if at least one of the inputs is 1, okay, so at least one of the inputs is 1, then the resultant value is going to be what? The 1 itself. 1 1 and 1. If not 0. Right. So this truth table is making some sense now. Right. And also we have right, I was showing you a program. We have taken two values. Okay. The value 1 5 is assigned to A and 9 is assigned to B. I want to perform the OR operation between these two values, between A and B. Right. So let me start performing the compilation and we will see the resultant value. Okay. File, save as. Let me save it as a.java. Right. Let me perform the compilation. Java C space a.java. Right. Followed by Java space save. So we are getting the resultant value output as 13. So why we are getting 13? Anyone have any idea? Sudhir, Prasanna, Purnima, or Lakshmi, Dinesh? Any idea about this?
So, if any one of the value has 1 in binary, it will get output as 1.
Okay. The resultant is
final resultant value will be 110.
Yes. Correct. Exactly. So I will just put the explanation into the actual picture. Right. If I take this as an example, what is happening behind the scenes? Just focus here. If you understand this, understanding the remaining concepts are going to be very easy. See, always. So for very few days, I will be giving you explanation just like I'm explaining it to kids. Okay, nursery level explanation I'm going to give. Please follow. Okay. So this is my class. Always remember, even when you are developing big applications or when you are limited to develop small applications, always remember this rule. Okay, the code that you are developing should call it as source code. Okay, source code should always get saved with .java extension. So this is how you represent this source code, by using .java extension. Okay, always remember the name of the file. The file name should be always same as the class name. Okay. For very few days I will be following this thing so that you will not forget. Okay, and you need to perform the compilation. Compiler will come into the picture. Okay, so compiler will take what? Compiler will consume the source code, which is a.java. Right, it will not directly consume the source code. You need to instruct your machine to perform the compilation. For that, the command is java c space, right, activate the compiler. Java c, hey, just activate the compiler. You are saying that just activate the compiler and do the compilation on top of a.java file. Okay, you are giving an instruction, activate the compiler. After the activation, compile this a.java. Okay, the moment you do this, this source file will be compiled by the compiler, and the job of the source file is to perform two checks, syntactical errors and semantic errors. After doing all the checks, if the code is error free, it will generate a file, .class file. Okay, a .class file will be generated and it will be placed inside the bucket. So once after the compilation, you should also perform what? For the execution, you need to perform you need to involve the JVM for the execution. Right, so compilation is successful and JVM comes into the picture. Right, this is JVM, Java Virtual Machine. Okay, and you need to activate the JVM. Okay, how would you activate the JVM? You need to pass an instruction. What is an instruction? Java space the class file name A. What does it really mean? A JVM get activated. So Java means activating the JVM, followed by which dot class file you want to load. You will specify it here. Okay, so the moment you give this command, this dot class file will enter into the JVM, right? And the JVM will start executing the dot class file. The first thing, JVM will create the main thread. Okay, main thread will get access to what? It will get access to the main method. First it will see if there is any main method or not. There is no main method, a direct error will be thrown. If the main method is there, its duty is to execute all the instruction. Now focus here what is happening behind the scenes. Okay, so this is a nursery level. For few classes I will be doing like this. A, so you are saying you are using a data type as byte and you want to store the value A, I mean you want to store the value 5 as getting assigned to the A. Now tell me, what is the size of the byte? Can anyone tell me what is the size of the byte data type? Yesterday we were discussing, the size. Anyone?
1 byte is equal to 8 bit.
Correct. But when I ask you what is the size of the byte data type, it's byte only, 1 byte only, right? So 1 byte means typically, okay, let me take this. I have designed this already. 8 bits of memory will be, okay, in the memory space, 8 bits will be created. 1 byte is equal to 8 bits. Okay, 8 bits will be created. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this will be created in the memory level, right? And okay, and what you are doing, okay, you are giving a name to it. Name is what? A. Okay, A is about the variable name. What is the value? 5. But 5 is a decimal number. Okay, 5 is a decimal number, but in the memory level, this decimal number has to get converted to binary number. Can anyone tell me what is the binary number for 5?
0101.
0101. Okay. Okay, what is happening behind the scenes? 1 minute. Okay, these are the, this is how I can represent, right? The 5 can be represented like this. Yes or no? Likewise, and what is the, okay, so because of this line, behind the memory, this has happened behind the memory, and the next line is what? Okay, the main thread will get want to execute the next instruction, which is byte b equal to 9. Yes or no? Right? For the byte b equal to 9, and again a memory will be created for the byte data type, right? And you want to assign the value 9. You want to assign the value 9, and you want to store it to what? And you want to assign a variable b. I mean, so this is what will happen behind the scenes. Right? And what is the binary number for the decimal number 9? Any idea? 4s are right?
1001.
1001, huh? Okay.
Yeah.
1001. So remaining spaces will be 0. Okay, very simple. Okay. After this, the next instruction is what? You want to display something in the console. So the main thread will get access to the next line, A or B. Okay. You want to do what? You want to do an OR operation between A and B. Isn't it? You want to perform OR operation between A and B. Just directly perform the OR operation. Okay. What is the rule? Did I say? At least if one of the values are 1. If at least any one of the inputs are 1. In this case, any one of the inputs is 1. So 1 is going to be what? Is going to be 1 itself, right? Okay. Second case. Okay. And if you take this 0 0 is going to be 0 only, right? And again 1 0, right? At least one of the inputs are 1, right? 1 0 1 0 1. One of the inputs is 1, so the output is 1. Remaining things are 0 0, so everything is going to be 0. Okay, you have got the equivalent binary number for what? For A or B. Okay, so after performing this, you want to do what? You want to display it in the console. So when you want something to get displayed in the console, it means the binary code needs to get converted to machine code once again. I mean decimal number once again. The binary number has to get converted to decimal number once again. So what is the things that we do? Just increase the significance of 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. Okay, so the places where you are finding 0, okay, don't consider that. Consider only the places where you are finding 1. So you can consider this, you can consider this, and you can consider this as well, isn't it? Okay. Now what is the output? 2 to the power of 3 plus 2 to the power of 2 plus 2 to the power of 0. All the ones places, all the one bits. Okay. 8 plus 4 plus 1. Right? 2 to the power of is going to give 8. 2 to the power of 2 is 4. 2 to the power of 0 is 1. It's going to be 13. So what is the answer that we got? 13. Okay. So now you tell me really quick, what is the output for this? Come on, I am giving you 15 seconds. A equal to 5, B equal to 5, and you want to find A or B. Do you have pen and paper next to you, or you don't have?
5.
Output is 5, huh? Okay, let's see. Compilation is successful. Output is 5. Are you getting it, everyone? So we have understood, okay, what are the possible how this output is being, what are the things that are happening behind the scenes to display the output in the console, especially when you use OR operator. Okay, directly, if you remember truth table, you can answer this very easily, right? And what is the next operator? Okay, next operator is what? Next operator is something like you have bitwise AND operator. Okay. What is the truth table for AND? Yesterday, if you remember, you can answer this to me. Let me introduce the truth table. Okay. We have any two inputs, A and B, right? And you want to perform AND operation between these two inputs. Okay, then the combination of inputs, like it can be 0 0 0 1 1 0 1 1. Okay. Always remember, if both the inputs are 1, or else you can remember like this: if at least one of the inputs are 0. Okay. If at least one of the inputs are 0, the output is 0. One of the inputs is 0, so output is 0. One of the inputs is 0, so output is 0. Is any one of the inputs are 0? No, it is not, so output is going to be 1. Very easy to remember. Okay, having said this, so same thing is going to happen. I will just change the symbol. Okay, let me take 5 9. Okay, and A and B. Okay, can you tell me what would be the output for this? Anyone? If you know this truth table, you already know the answer. Okay, you can just consider the same example which you have done before, but you want to perform the, what did you say, Sudhir? 1 Java C space A dot Java. Okay. Java space A. 1 is the answer. Okay. Why 1 is the answer? Let me repeat this. Okay, let me take the same bits. Okay, so now, so this is A. Okay, this is what? This is A and this is B, isn't it? Go to the example and see. A and B. A is 5, B is 9. Okay, this is the equivalent binary number for the decimal number 5, and this is the equivalent binary number for the decimal number what? We have 9. Right? And we want to perform AND operation. What is the rule? If at least any one of the inputs are 0, in this case both are 1. Okay, output has to be 1, right? So in this case both are, 1 is 0, so 0. So here 0, you have 0 only. So one of the inputs are 0. In this case this is 0, so this is going to be 0. So remaining things are 0 only. Okay, and if you convert this binary number to its equivalent decimal number, you are going to get what? You are going to get output as 1. Making sense? Okay, now you tell me, okay, 5, 6. Tell me what could be the output for this. Anyone?
4.
4, let's say. Yes, correct, 4. Hope you're getting this. Okay, now let us see. Okay, let us go back and see the another table. What is this? The next operator is what? The next operator is we have the caret operator. So you call this as caret, C-A-R-E-T, not the vegetable carrot. Caret. Okay, XOR. So the truth table for XOR operator is as follows. Okay, let me draw the truth table really quick. A, A, B, A, XOR B. Okay, so 0, 0, 0, 1, 1, 0, 1, 1 possible combinations. Okay. What does this operator really says is, if you find two inputs are same, okay, if the two inputs are same, in this case two inputs are same, two inputs are same, A and B are same, A and B are 0, in this case A and B are 1. If you find two inputs are same, output has to be 0. Okay. If you find dissimilar inputs, the output has to be what? Output has to be 1. Making sense? If two inputs are similar, 0. Okay. If two inputs are not similar, 1. Okay. Having said this, now can you find the XOR for what combination we can take? Same example, 5 and 9. Huh? Can you find? Okay. The takeaway is, if two inputs are similar, 0. If not, 1. Just keep a pen and paper next to you so that it will be very easy. This is the truth table.
12.
12, huh? Okay, let us say. Correct. Why 12? Let me explain it for others. See, these are the same example I am taking. Okay, this is for 5 and this is for 9. Okay, two inputs are same. If you see, two inputs are same, right? 1, 1, same. So 0. Two inputs are same, right? 0. For similar inputs, 0. For the non-similar inputs, 1, right? It is 1. Okay, 0, 0, 0, 0. Right? Just raise the power 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. We don't need to calculate when the bits are 0, you don't need to do this calculation. Only you need to analyze the calculation when you find the bits are 1. Okay, these two you can take. So 2 to the power of 3 is what? 8, plus 2 to the power of 2 is what? 4. Right? So this is all about the XOR operator. Okay. Now, can you find this? Can you find this? Don't take any. First find this two. Okay, then find this two. Then the two resultant value should be. So I'm just using all the possible combinations, all the possible operators.
12.
12. Any other answer?
12.
12 only. Let us check this. Okay, my mistake. So one parenthesis is missing. Java space 8.java, Java space. Correct. Okay, I hope we're able to getting this. Now we are getting this, right? Why others are not answering? Purnima, Lakshmi, Dinesh Kumar. Are you understanding it or not? Able to follow? Dinesh? Lakshmi? Lakshmi is always silent. She will only wish me morning, good evening. That's it. Are you able to understand, Lakshmi? Dinesh, are you there or not? Dinesh? Dinesh, you're not speaking. Just unmuting. That's it. Okay then. So let's continue. Let's discuss the remaining. What are the next operators? We have something like what? Let me go back to it and see. Okay. So you will understand this bitwise complement later, little bit later. Okay. The first of all, let us understand what is the left shift operator and what is the right shift operator. Okay. So left shift and right shift. Let us do the left shift first. So for this, I don't think you require notes. These are the basic operations, so I'm not going to give any notes for this. Okay, you can just follow my video if you have any doubts. So left shift operator. Okay. So it is what? Two angular brackets pointing towards the left. Two angular brackets pointing towards the left. I want to calculate something by using left shift operator. In my example, I want to keep the a like 5 only, right? And I want to do okay, a left shift 1. First, let us try to see what answer we are getting, then we will start analyzing. Okay, let me do the compilation java c space a.java, then java space a. So we are getting something like what? We are getting something like 10. Okay, why we are getting 10? We will understand that now. Okay. So what is the value? What is the equivalent binary for 5? We know this already. Okay. Let me take focus here, guys. This is something not tricky, but we will use this. We will try to understand all the primitive data types by using this bitwise operators. Understanding that will become very easy if you understand this. Okay, so I want to do what? I want to do the left shift operation on top of the given number 5. Okay, left shift to 1. What is the answer that we got? We have got 10. Why we are getting 10? We will understand that. Okay. What is the binary number for 5? We know this already. It's 101. Right? 101 is a binary number. 101. Okay, remaining values has to be what? 0, 0, 0, 0. Okay, now focus here. Let me take the same set of memory block, which is 1 byte. The moment you do left shift, okay, focus here. Okay, this operator is very important. Okay, this operator, left shift. You are using two angular braces. You are doing what? You are performing the left shift operator. You are using what? Two angular braces. Okay, the moment you do left shift, each and every bit. Okay, each and every bit will be shifted 1 bit to the left. Okay, so the 1 will be shifted 1 bit to the left. So this 1 will occupy this place. Okay, this 0 will be shifted 1 bit to the left. This will occupy this place. This will occupy this place. The remaining this will occupy this place. 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 Isn't it? Okay. Why only it is getting shifted to only 1 bit? Because you are using 1. Left shift 1. It is representing what? 1 bit. Just left shift to the 1 bit. Right? So, and this value, okay, you are going to get a value which is not going to have any memory block. So this is the overflow value. Okay, it will be void. It is overflown. It has just disappeared because you are using what? You are using byte, so you cannot have any more spaces for this particular 0. It will be overflown, right? And there is a space created here. Okay, there is a space created here. That space is called as void. Okay, on which value we are going to use to fill this void? To fill any void, especially by using the left shift operator, to fill the void spaces, you use what? You use 0. Okay, what we have just performed, we have 5, we have just left shifted to 1. 1 means what? To 1 bit. Left shifted to 1 bit. Okay, so each and every values will be left shifted to 1 bit. Okay, there will be a loss, a minor loss, so there will be no space for this, so that is going to get disappear. Right, now you calculate the equivalent binary number for this. What is equivalent? I mean, equivalent decimal number for this. This is already binary number. You want to calculate equivalent decimal number for this. So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. So you will consider only the one bit places. These two are the 1 bit places, right? So 2 to the power of 3 plus 2 to the power of 1. Okay, so 8 plus 2 is 10. Making sense, everyone? Yes, no?
What if it has 1 at 0 place?
Okay, good. That we will see here. You are asking about which one?
Yes,
Here,
at the left mode.
left mode. No issues. Even if you have 1 also, that will be overflown. No issues.
Okay.
You will understand now. Shortly, you will understand. We will see one more example. Now you tell me what would be the value if I use 2. Calculate and tell me. Just use this left shift operation. Now you tell me what would be the answer by if you left shift a particular number with 2.
Twenty value.
Value 20. You all agree with Sudhir, everyone? Prasanna, Purnima. Let us see. Java C space A dot Java. Right? Java space A. So 20 is the right answer. Okay. Okay, this time what we want to do, we want to left shift a number with 2. Previously it was 1. So only 1 bit. We are going to left shift it to only 1 bit. This time this is 2. Okay, focus here. I'm repeating this for the one time. See, for the second time. Focus here. Okay, let's use this space. Focus, guys. The same number. I want to use 5. I want to left shift the 5 with 2. Okay, so 101 is the binary number for this decimal number. The remaining spaces will be 0. Okay, and I'm using a left shift operator. So this is the left shift operator, right? And I want to do what? I want to left shift it with the number 2. 2 means this time, okay, it will be left shifted by leaving 2 spaces. Previously 1 spaces, this time 2 spaces. Okay, this one will occupy here. Okay, this will occupy here, 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 and this will be overflown, this will be overflown. So you will not consider these two, right? Let us keep the values like this. Two to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. Okay, just consider the 1 bit powers. You have 2 to the power of 4 plus 2 to the power of 2. 2 to the power of 4 makes what? 16 plus 2 to the power of 2 makes 4. 20. Right? 20 is the answer. Right? Now you find for left shift 3. Okay, we are getting a pattern. I will tell you what is that pattern. Now tell me the answer for left shift 3.
40.
40, good. This 40. If you observe one thing here, a pattern is getting developed. The Java space here. What is the answer? If you observe one thing, a pattern is getting developed. Sir, what is that pattern that you're talking about? Okay, if you take the number 5 and if you keep it, if you increase the left shifting, okay, firstly we did what? 5 is left shifted to 1. What is the answer that we got? 10. Second one what we did? 5 again left shifted to 2. So we got what? We got 20. The third time 5, okay, the value 5 is left shifted to 3. Okay, we got what? We got 40. Okay, every time the number is getting doubled. Okay, 5 if you do it 1, it is getting doubled. Okay, 5 if you do it 2, okay, it is getting doubled. 5 you do it 3 times, it is getting doubled with the powers of 2. Okay, I can write it like the left shift operator is doing what? It's actually doubling the number from the original size. With the powers of 2. We keep it like this, doubling the number from the original size. So if I ask you to do it for 1, okay, what it is actually taking from, what is happening behind the scenes? If I do it 5 left shift to 1, okay, it is taking like 5 into 2. 5 into 2, right? And again, if I do 5 left shift to 2, it's taking 5 into 2. Okay, the whole thing again it's getting multiplied with 2. This is the pattern. Okay, and if I take 5 left shift 3, okay, consider this whole thing, and this whole thing is getting multiplied with what? This whole thing is getting multiplied with, is getting doubled with 2 into 2, right? If I take 5, so by looking at this pattern you can answer this. If I do 5 left shift 4, okay, what is the answer? This whole thing will get doubled. What is the answer? Can anyone tell me? 5 left shift 4. 80, right? So by looking at this pattern, I can conclude that 5 to the power of what? I can say, or else I can conclude like this. The pattern is like 5 into 2, 5 into 2, 5 into 3. So I can say that 5 into the number that you are taking into 2 to the power of n. So this is the formula. Can I conclude like this? Yes, I can conclude like this. Because your number that I am talking about is 5. Whatever the number that you have, that is the number. Okay, into 2. 2 is the base to the power of n. This n is what? The n is the number that you are giving it after the left shift operator. You are giving it 2, this n becomes 2. You are giving it 4, this n becomes 4. You are giving it 5, the n becomes 5. Okay, in future in the interview room, if they are asking you, okay, you can just directly go with the formula because this is the actual pattern. Will it really work? Okay, let us apply this formula for the number 5. Let us apply the same formula for the number 5. Okay, I want to use the number. Okay, I want to say 5 left shift of 5. Okay, so this 5 is what? This 5 is n. This 5 is the number. Okay, this 5 is the number. Let me connect this to. Okay, this 5 is the number. Okay, and this 5 is what? This 5 is n. Okay, 5 into 2 to the power of 5. So 32 into 5. Am I correct? 160 should be the answer. Right? Are we getting 160? Let us check. Making sense, everyone? Yes, no? Answer, Sudhir. Prasanna, Purnima, Dinesh, right? So now we are good about what? We are good about the left shift operator. Now next let us understand about the right shift operator. Only 3 more operators are pending. Right shift operator. So this right shift operator is a little tricky part. Your attention is required here. Attention is required. So don't think that I'm scribbling here. Okay, so this is how we can learn the programs. So there is no theory. That's the reason why I'm doing all this. Anyhow, I will share these things with you. Okay, but before that, let me do something here. Let me take the new notepad. Today's class 30. We have completed 30 classes. Okay, every day we will have these problems. Every day. Okay, now right shift operator. So right shift operator. Right shift operator. So right shift operator, the symbolically you can use these two symbols. Okay, two arrow keys or arrow tokens pointing towards the right side, or two angular phrases pointing towards the right side. You can also call this as arithmetic right shift operator, or signed right shift operator. So let us understand these things practically. Focus here. Same thing. I am just changing the right shift. The same number I am taking, but I'm instead of left shift operator, I am using right shift operator. Let us see the answer. By that answer, we will conclude how it is calculating the things behind the scenes. What is happening behind the scenes? The Java C space A dot Java, Java space A. You are getting something like 0. Okay, let me right shift it to 1 first. Okay, let me right shift it to 1. There is a minor change here. It's not like what you are thinking. It is not like just we will be right shifting. It is not like that. Okay, so this is what we want to do. We want to right shift to 1. Okay, what is the value of A? Value of A is 5. What is the binary equivalent for the 5? We know this already, 101. Right, and the remaining things will be what? Will be 0. Okay, when I say right shift 1, when I say right shift 1, what does it really mean? One bit will be right shifted. Each and every bit will be right shifted for one time. Right, I can conclude it like this. Okay, this bit will be right shifted, so it is getting eliminated. Okay, this bit is going to occupy this position, right shifted, right shifted, right shifted, right shifted to the right side for one bit. Right, let me place the actual values after the right shifting. 0, 1, you have 0 here, you have 0 here, you have 0 here, you have 0 here, you have 0 here. Okay, now the question arises. A void is happening here. There is a void space here. Okay, a void is getting created. Always remember, especially for the right shift operator, this rule is applicable for the right shift operator. Okay, always remember, when the void is getting created, okay, just try to find what is the value of the bit on the MSB. So I have said you yesterday, right? MSB is what? Most significant bit. The leftmost bit is called as MSB. The value of MSB is 0. Okay, fill that void with 0. Or I can say that fill the void or space with the value of MSB from the actual number. If it is 0, okay, fill it with 0 only. Fill it with 0 only. Okay, after doing this, what is the equivalent number now? What is the equivalent number that I will get? I just rewrite this to the equivalent decimal number. Okay, just I will raise the powers, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and so on. Everything is 0, so I do not have to calculate this. I will have to calculate just the 1 bit power. 2 to the power of 1. 2 to the power of 1 is what? 2 only. So the answer is 2. 2 is the answer. Okay. Now you tell me what is the A right shift of 2? Come on.
1.
Okay. So there is saying 1. Yes, it's 1. Obviously it is 1. Why it is 1? So you want to do what? You want to, this time what happens? Okay, let me. So again, I can either do it directly, or I can do it directly, or I can do it from here also. No issues. It is going to be easy. It will be right shifted. This will be right shifted because this binary number is already right shifted to 1. So if I want right shift it to 2, I can do it. I can redo it for 1. Right, and this will occupy this, this will occupy this, this will occupy this, this will occupy this, this will occupy this. A void will be created. Fill that void with 0, and the remaining values are going to be 1 0 0 0 0 0 0. It is going to be 1. So 2 to the power of 0 is called. Okay. And if I keep doing it, if I keep doing it 3, okay, it is going to be 0 always. Okay, 4 0 always. Making sense? 5 0 always. At one point you will be getting 0 since you are doing the right shift. You are getting it. Okay, from this, what is the pattern that we can understand? From this, what kind of pattern is getting created? Okay. Every time the actual number is getting divided by 2. Every time the actual number is getting divided by 2. Focus here. Someone is calling me. Just keep on calling. 1 minute. Focus here. Let us say that you have a number getting right shifted to 1. Okay. In our case, the number is 5. Okay. And every time it is getting divided by 2. You can say, sir, when the 5 is getting divided by 2, the output has to be 2.5. Okay. But it will consider only the quotient part. When I say quotient part, it will not consider the remainder. Okay. 2 divided by 5, 2 2s are 4, balance is 1. So this is going to be the answer every time. It will not consider the fractional part, it will consider only the decimal part. Okay, and next question, we have also done number, okay, right shifted to 2, right? Same time 5 divided by 2. Okay, again this whole set is going to get divided by what? Divided by 2. Okay, it is going to be like 5 divided by 4. Mathematics, 5 divided by 4. When you do this, 4 divided by, divide this, 4 ones 5, 4 ones 4. Hey, what is happening? 4 ones 4, remainder is going to be 1. So the quotient part is 1. Let me rewrite this once again. Five right shift of 1 is nothing but 5 divided by 2. 5 right shift of 2 is nothing but the 5 divided by 2. Okay, this whole thing will get divided by 2, right? 5 right shift of 3 is nothing but, okay, 5 divided by 2. Okay, this whole thing will get divided by 2. You see the pattern. The pattern is like, okay, the actual number that you are giving divided by 2 to the power of, okay, the number to how many shifts you want to do. Shifting number. If you apply this formula for this, okay, number is what? Number is 5 divided by 2 to the power of, what is the shifting number? 1. Okay, you get what? 5 divided by 2. On further evaluation, okay, you do what? You do like this. So 2 times 4, remainder is going to be 1. You will consider only the quotient. Quotient is what? 2. So that's why the answer is 2. Okay, if you want me to explain this, 5 divided by 3. Okay, 5 right shift to 3. Okay, 5 divided by 2 to the power of 3, because 5 is a number that is occupying here, 3 is a number that is shifting number. Okay, and 2 is the actual base. Okay, 5 divided by 8. If you do this, 8 by 5, okay, just to be what, 0, I mean it will only consider the quotient part, right? So 800. So answer is 0. Now, making sense for the right shift operator, okay, the formula is the number divided by 2 to the power of number. For the left shift operator, number into 2 to the power of shifting number. Making sense, everyone? This is for left shift, and this is for type yes in the chat box if you understood so far, or any confusion is happening. Everyone?
What if it is a decimal?
Which one?
If a equal to 5.5.
Okay, good question. I have been telling you, right? If you want to use the byte data type, byte can hold only integral numbers. Okay, for the floating point things, there is a separate what we call it as classes for that. We will discuss that in the future topic. This is applicable only for the integer numbers, because you cannot assign 5.5 to the byte data type. Fractional parts are not accepted for the byte data type. Is it making sense? For the
Yes,
floating point value, we will use IEEE floating point method. That is something that is a future topic. That is a little bit complex topic. This is applicable only for the integral, because binary number are meant for only the integers, and to generate the binary number for the fractional part, okay, we will use IEEE pattern. That is different. Okay. Now your question has to be what? Your question has to be like, sir, what if my number is -5? What if the number is -5? What if I do, okay, a right shift, or let me take a left shift, this a right shift of 1 by using what? By using the negative number. Positive numbers, I am fine with the positive numbers. What happens if I use negative number? What happens if I start using negative number? Right? What will happen? Let us see. Now let us try to find the answer for this. We are getting -3. Why we are getting -3? We will just follow our pattern. Okay, let me take these 2 bits of lines. We will just follow what we have been doing so far. Okay, this is our question. Okay, -5. Right, first try to find the equivalent decimal for +5 first. Try to write equivalent decimal value, I mean equivalent binary value for the +5. First of all, we will try to find that. We know what is it. We know it is 101. Okay, 101 0 0 0 0 0. Right, so this is the +5. For the +5, this is the equivalent binary number. Okay, actually I was telling you, in order to find the negative numbers, we have to do what? We have to do the 2's complement. Do you remember? So you cannot directly do the 2's complement. First of all, you need to do the 1's complement. What is the 1's complement? Okay, you will just flip the numbers. Flip the numbers. If it is 0, you take it 1. If it is 0, 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 1. If it is 1, 0. If it is 0, 1. If it is 1, 0. So now you got the actual value for 1's complement. After getting 1's complement, you need to perform 2's complement. 2's complement is what? Adding a 1 to the 1's complement. Right? When you do this, okay, the resultant value is going to be 1 1 0 1 1 1 1 1. Making sense? Now, okay, let me put this in all the boxes, right? Okay, after having this, we need to consider what? We need to consider MSB. Don't get any confusion. Okay, I'll repeat this once again. So this is MSB. We have to consider what? We have to consider MSB, most significant bit. Okay. So after finding the most significant bit, what you are trying to do, you are right shifting it to 1, right? You are right shifting to 1. So everything has to get right shifted to 1. Yes or no? Or else let me take this. Let me take these boxes. I am explaining this for the negative number. Okay, we have the negative number 5. If we have negative number, first you will do 2's complement, but you cannot directly do 2's complement, right? You cannot directly do 2's complement. Instead of that, first you will do 1's complement, then you will find 2's complement. After finding 2's complement, what you will do? After finding 2's complement, okay, you will mark the MSB as 1. This time the most significant bit as the 1 value. The value 1 is there. Okay, now you just right shift it to 1. Okay, this 1 will get eliminated. This 1 will get eliminated. So this 1 will occupy this position. This 0 will occupy this position. This 1 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 will occupy this position, and this 1 will occupy this position. Okay, now the question. Okay, if the MSB is 1, fill that the void space. Fill the void space with the actual MSB value, which is what? Which is 1 itself. Right? So now, okay, now you have done the shifting. Let me repeat, guys, very simple. If you have a negative number, for the positive number, directly shifting you can do, no issues. But if you find the moment to find the negative number, okay, in this case we are having a trouble. You have something like a equal to -5, a negative number. Okay, so you will find the binary equivalent for the positive number firstly. Okay, the binary equivalent for the positive number needs to be found. Okay, after this, okay, since this is a negative number, the signature is minus. Okay, you need to do 2's complement. So directly can you do 2's complement? No, you cannot do directly 2's complement. First of all, you need to do 1's complement. Okay, so this is the resultant of 1's complement. Okay, and to do 2's complement, add 1 on top of upon 1's complement. Okay, you will get this number. After getting this number, you will do what? You will do the actual right shifting here. Right shifting. Okay, after performing the 2's complement, you will do right shifting. Okay, after right shifting, you have got this answer. But the question now again, you cannot directly convert this binary number to the decimal number. Instead of that, you need to undo 2's complement. Undo 2's complement. When I say undo 2's complement, it is just opposite. To do 2's complement, first thing we will find 1's complement. Okay, then we will add 1, right? So this is the procedure to find 2's complement, isn't it? This is the procedure to find 2's complement. If you want to do 2's complement, this is a procedure. First find 1's complement, then add 1 on top of it. If you want to undo 2's complement, okay, undo. This is doing, and I want to undo now. I want to undo it now. If I want to undo, okay, firstly I want to do what? Firstly I want to remove -1. I mean subtract 1. Okay, then I need to flip. I need to undo 1's complement. Opposite, just the opposite, just the reverse order. When I say that, so I need to do -1 here. Okay, you will get something like 0 0 1 1 1 1 1 1, right? After this, I want to undo what? I want to undo the 1's complement. If I undo 1's complement, okay, this 0 becomes 1, 0 becomes 1, 1 becomes 0, 0 0 0 0 0, right? Then you will do what? Then you will find the equivalent binary number for this. So this is 2 to the power of 0 plus this is 2 to the power of 1. Everything is 0, so you will not consider everything remaining things. What is the answer? 2 to the power of 0 is 1, right? 2 to the power of 1 is 2. You get 3. You get 3. But since, okay, you have done 2's complement, you have done 1's complement, the most significant bit was 1. When you are doing 2's complement, you will add a negative sign. Very big, isn't it? That's why the output is minus 3. You see, minus 3. Let me repeat it. For positive number, directly you can do a okay, but when you have negative number, firstly, okay, calculate the equivalent binary number for the given for the positive number, then do the 2's complement. Okay, you will get some number. After doing the 2's complement, then perform right shifting. Okay, you will get again one binary number. After right shifting, you cannot directly convert this binary number to the equivalent decimal. You should undo the 2's complement. Undo means -1 and flip the numbers. Okay, you will get the resultant value. Okay, you will find the decimal number for this. Then add a negative signature. Making sense? This is all about right shift operator. Okay, so that's why the right shift operator is also called as what? If you see, I have said signed right shift, right shift operator. Signed means you will consider negative signs also. Okay. Tomorrow we will find the remaining possible combinations. What I am going to do,